it's the big day, and unfortunately the weather forecasters have given us a 10% chance of a go due to the afternoon thunderstorms that had been happening every afternoon about our lunchtime. So we proceed to the pad with anticipation, hoping that possibly the weathermen are wrong. We get all strapped in. Takes about an hour to strap us all in and get us all set, ready to go. We have to get our gloves on, our helmet on. And it's challenging getting into the vehicle while it's in the vertical. And we have a couple of people that help us strap in and make sure that everything's put together right. As you see, it starts raining about an hour before launch, and we're beginning to think we might not get to go. But lo and behold, the sun shines through. And 6 seconds prior to liftoff, the main engines come up. The GPCs see good main engines. The SRBs light, and off we go. You can see the vibrations inside at liftoff. It appears pretty violent. But that happens pretty rapidly, and then we start feeling the onset of Gs. We go from 1 to 3 Gs in the first couple of minutes of the flight up until the SRB separation point. When the SRBs separate, we can see a flash inside the cockpit, and we can also feel it. After the SRBs separate, we go back to 1G, and it feels like a huge weight has been lifted off of our chest. And then we go slowly back up to 3Gs as we approach main engine cutoff 8.5 minutes later. And for the last 2 minutes, we're under that high G forces, feeling like we have elephants sitting on us. So here the elephant finally gets off of our chest, and we're in orbit.
One of the first things we have to do to get ready for payload operations is open the payload bay doors. That inner surface is a radiator that allows us to get rid of waste heat so we can turn all the experiments on without getting the orbiter too hot. Once we get the doors open, then we're ready to go activate the Space Lab module. You saw it there briefly in the payload bay. This is it from the inside. That's me coming into the module. Roger will be coming in right behind me. We get all the equipment powered up in the subsystems. We turn on the lights, turn on the communication system, get the water loop running, get all that equipment ready so we can run experiment operations. Crew is always anxious, especially in the first few days, to see how the experiments are going to do. And we had a mob here collected around one of the combustion experiments to see how the early runs would go. And sure enough, the run went really well.
One of the big areas of research was combustion. And right here, I'm trying to adjust the flame height for one of the experiments. The purpose was to find the point at which soot was just forming. There's the igniter. The flame is actually going to be pointing down in this image. Here the fuel is coming out and it's lighting. You can see it's making a lot more soot than expected, and so we had to quickly adjust the flow rate down. The purpose of this experiment is to understand soot formation so we can make devices on Earth that make less soot and pollute less. Another experiment that we had, here's the laser extinction view of that same flame. The dark areas correspond to high soot concentration, and this was very unexpected. We didn't expect that much soot. Another experiment was to study very, very lean combustion, as would be important for lean burning engines. These were some of the weakest flames ever burnt anywhere, and they were in dilute hydrogen-oxygen mixtures. Both of these experiments were very, very successful.
Our third major combustion experiment was a droplet combustion experiment. We formed what was essentially gasoline in little droplets and burned it so you could study how the fuels burn as in a droplet of flame in a fire. We had several different ways of looking at the flame once the droplet's been formed. You see it there forming between the two needles. It's deployed, ignited. On the left view is a visible light. On the right view is ultraviolet. You can see how you can get different science from the two different views of the flame.
An important concept we wanted to demonstrate on this flight was the ability to transfer experiments, say, from the middeck of the space shuttle to a space station, which is something we'll be doing in the future. Here we had an experiment called Astro PGBA, a small greenhouse. We launched it in the middeck of the shuttle, and on about day 2, Susan and I transferred it back to the space lab. We unpowered it, unhooked it, and took it back there and bolted it into our Space Lab module into a rack called the Express Rack, which will be flying in the future on space station to accommodate these types of experiments. And our goal was just to practice this transfer to see how it would work on orbit, and it did a great job. And then later on the mission, right before we came home, we transferred it back to the middeck again.
We had another experiment on board looking at transfer operations. This is the combustion that you just heard about, and I'm taking out the one that had the soot production, and we're going to put in the one with the weak flames. This is another space station concept that would allow you to develop new experiments as the space station ages. You could remove one set of equipment and bring up from the ground a new set that's been designed for the new experiment.
Besides the combustion work, we had a number of material science experiments. I'm working at a facility here called the Large Isothermal Furnace. This is a Japanese facility, one of the two international partners we had on board. I'm putting a new sample into the chamber here, and it's a highly automated facility. This is one of the German facilities called Tempest. It's an electromagnetic levitation furnace, and you can see the round sphere on the right is a small molten material that's heated up and spinning around and bouncing around there as we process it.
A couple of the secondary payloads that I had the opportunity to participate on. Here's one, a handheld diffusion unit. We actually grew protein crystals in here, hopefully, which might lend to the development of some new drugs having to do with the easing the effects of asthma or antibacterial drugs. Diabetes is another area of interest. We also grew several varieties of plants. Of course, if we ever expect to spend a long time in space, and we do, we need to learn how to do that in zero gravity.
A nice little workstation called the Glove Box provides power and cooling for different experiments that are relatively small, usually a complement of some of the other experiments on board. This particular one is a complement to the droplet combustion that Janice talked about. You can see in the center of the screen there two little round ball-looking things. Those are little droplets of fuel. It's the first time that anyone's ever ignited two flame balls simultaneously like this. They were able to get a correlation between the larger facility and this facility so that we were able to run 60 or 70 runs here. Other experiments that we did in this area had to do with some containerless processing using ultrasonic waves. We also had some capillary heater or heat transfer tubes that heat transfer differently in space using a mechanism called heat pipe. They've been failing in the past, and we were able to observe a failure mechanism to possibly help alleviate some problems they've had before.
We got into a nice routine over the 16-day flight, and typically that routine started out with getting a fax from the ground on the tips. This is me doing an IMU align where we mark on some nav stars and update our IMUs. The other thing we had to do is get messages up on the computers, and that's Susan dealing with the daily uplink messages. And typically, little things can go wrong. We had almost a flawless mission. This is Roger and I doing an IFM where we had to rewire a thermocouple connector on the LIF furnace. And the ground researched it and faxed us up a procedure, and it worked just fine. This is Jim on the SARX radio, the amateur radio experiment, talking to some school kids around the world. That was a lot of fun for us, and they sure did a good job on that. Here's Janice hanging like a bat from the mid-deck escape pole, working on the computer. And we tried to position the computer such that there wouldn't be traffic jams, and sticking it on the roof was a good place to do that. This is the red shift going to sleep, trying to do formation flying. There's Jim kind of messing up there, but and these are the sleep stations. You can see them closing the door. We got little straps that we use to hold us down, but typically your back hurts if you try to strap yourself in, so some of us would free float in the sleep station, but the problem was you'd wake up and it'd be pitch black and you wouldn't know where the door was. Here's Greg washing his hair with the famous rinseless shampoo that accumulates over 16 days. It's kind of like a camping trip with 7 people, and of course there's only one bathroom, so everybody has to wait in line. And there you see Jim brushing his teeth while Janice changes her clothes to get ready to go exercise. Exercise is a real important part of our daily operations. We carry pretty much the same personal hygiene items that you would use on the ground. There's Greg shaving, and here's Don exercising on the ergometer. Off to the left there you see the valuable duct tape and Susan's Fruit Loops. That must have been early in the flight. We also had these Dynabands, and here's Susan doing a little leg workout. And there's me getting ready to cook some spaghetti. The food was great. We all ate very healthily, and no one really lost too much weight. There's Janice eating some of her famous birdseed. And Roger sneaking a bite back in the lab.
One of the advantages I had was I was assigned prime on the Earth observation program, which has been ongoing since the beginning of our space travel, actually. So I got to spend a lot of time looking out the window. And the Earth is a beautiful sight. Here you see the Strait of Gibraltar Africa is in the bottom part of the screen, and Spain and Europe are in the upper part. And this is the Bahamas, one of the most beautiful parts of the world, I think, due to the colors. But oceanographers and meteorologists and geologists are all interested in the types of photographs that we take from space. For instance, the folks in the weather office are interested in these von Karman vortices off the Canary Islands in Africa.
Even a 16-day flight eventually comes to an end. This is Susan packing up some of the equipment back in the Space Lab module. We do a little bit of packing as we get to the second to the last day, and then Jim and Susan check out the orbiter systems with Mike's help to make sure that the jets are working and the aerodynamic services will function properly so we can get safely back home. And then we finish up with the final closeout of the Space Lab module. All the experiments get shut down in a very orderly fashion, so we make sure all the science gets preserved and will survive the reentry and come back and allow everybody to analyze all the work that we were up there doing for those 16 days. The last payload activity is close the payload bay doors. We don't need the extra heat rejection capability anymore, and once those doors get closed, we'll be coming home in just a few hours. Start the deorbit burn and head back to Kennedy Space Center.
We had a nighttime entry, and it was pretty spectacular looking out the overhead windows, as you'll see coming up here. These are the flashes out the overhead window as we enter the atmosphere, the plasma ionization going off. It starts off just as bright flashes like giant flames, much larger than anything we'd seen in our combustion chambers. It changes after about 5 minutes into this little inverted mushroom structure you can see glowing there, and a few minutes later it develops this white, yellowish bright white structure just glowing out there. It was really spectacular watching it for 10 or 15 minutes on entry. And this is a view as we passed over Houston at about Mach 10 or so, and the people on the ground said they had a great view, and we had a great view out the window also of the glow.
Entry is spectacular, just in a different way, but just as interesting as ascent is. The crew's suited up and fired up here for the last task of the flight, which is to land successfully. Here's a heads-up display view of the information that's projected in front of Susan and myself in our windows as we look outside. In the insert, you can see us flying around that large heading alignment cone, the actual turn on to final approach to the runway. When we do roll out on final approach, we dive down at a steep dive angle, 18 degrees, about 6 times greater than what you would in a normal airliner. Of course, we can't land like that, so at 2,000 feet above the ground, I pull the nose up to a more normal 1.5 degree interglide slope. Here we are at 300 feet. In the upper left-hand signal, you see the GR. That's for gear. That means that Susan has just put the gear down at 300 feet as she's supposed to. I guide the aircraft down to a safe landing 3,000 feet down the runway, and just about at our design speed of 202 knots indicated airspeed. At 195 knots, I put the nose down, and Susan pops a chute. It inflates right there just before the nose hits the ground so as to cushion the impact of the nose wheel slap down. And it just worked exactly the way the engineers had designed it to. That concludes our 16-day flight. Hope you enjoyed the film.
It's the big day, and unfortunately the weather forecasters have given us a 10% chance of a go due to the afternoon thunderstorms that had been happening every afternoon about our lunchtime. So we proceed to the pad with anticipation, hoping that possibly the weathermen are wrong. We get all strapped in. Takes about an hour to strap us all in and get us all set ready to go. We have to get our gloves on, our helmet on. And it's challenging getting into the vehicle while it's in the vertical, and we have a couple of people that help us strap in and make sure that everything's put together right. As you see, it starts raining about an hour before launch, and we're beginning to think we might not get to go, but lo and behold, the sun shines through, and 6 seconds prior to liftoff, the main engines come up, the GPC see a flash inside the cockpit, and we can also feel it. After the SRBs separate, we go back to 1G, and it feels like a huge weight has been lifted off of our chests. And then we go slowly back up to 3Gs as we approach main engine cutoff 8.5 minutes later. And for the last 2 minutes, we're under that high G forces. See good main engines, the SRBs light, and off we go. You can see the vibrations inside at liftoff. It appears pretty violent. But that happens pretty rapidly, and then we start feeling the onset of Gs. We go from 1 to 3 Gs in the first couple of minutes of the flight up until the SRB separation point. When the SRBs separate, we can feeling like we have elephants sitting on us. So here the elephant finally gets off of our chest, and we're in orbit.
One of the first things we have to do to get ready for payload operations is open the payload bay doors. That inner surface is a radiator that allows us to get rid of waste heat so we can turn all the experiments on without getting the orbiter too hot. Once we get the doors open, then we're ready to go activate the Space Lab module. You saw it there briefly in the payload bay. This is